All right, so we're going to talk about section 7.5. And what 7.5 deals with is solving equations with logarithms. Okay, so it might involve logarithms, it might involve exponentials with variables in it. But either way, you're going to have to use logarithms in order to solve. So it's going to use 7.3 and 7.4 in order to solve these equations. Okay, so the first equation that we got to solve is log base 6 of x minus 2 plus log base 6 of x plus 3 is equal to 2. Okay, notice these two are the exact same. So log base 6 and log base 6. If these were not the same, okay, then it'd be a whole different thing. But since they are, we can combine them. Okay, so I have one log base 6, okay, and there's a plus in between. Okay, so if there's a plus in between, we would multiply these two things. Okay, so x minus 2 times x plus 3. And we know that's equal to 2. Okay, so now since there's still variables in there, what I could do now is convert this to an exponential. So the base is 6, so 6 squared, 6 to the other side, is equal to, and then I can FOIL this out. X times x is x squared, minus 2x plus 3x, which would be positive x, and then minus 6. Okay, 6 squared is 36. Is equal to x squared plus x minus 6. Subtract this over, solve. X squared plus x minus 42. 6 minus 36 is negative 42. And then factor to solve. 0 is equal to x, two numbers that multiply up to 42 but add up to 1. That'd be x plus 7 and x minus 6. So my two answers are x equals negative 7 or x equals 6. Now, what you're going to have to do, especially when you're having to solve for variables that are inside a logarithm, notice that if you typed log of like negative 1 in your calculator, okay, this would say no solution. Okay, and it does that like log of negative 6, log of negative 5, so on. Okay, because you cannot do a negative, and if you remember what the graph looks like, okay, it's something like that. Notice the domain, you can't do any negative values. Okay, so you need to make sure that if I would plug these in, I cannot have a negative number in the logarithm. Okay, so if I plug negative 7 in, negative 7 minus 2 would be negative 9. So this automatically doesn't work. But could I plug 6 in? 6 minus 2 would be 4. That's positive. And 6 plus 3 is 9. Okay, so that's positive. So my answer is x equals 6. Okay, so combine. Anytime you have two logarithms, you combine it, then you turn it into an exponential and solve it out. Okay, all right. So the next one. Okay, so we have log base 2 of x minus 2 minus log base 2 of x plus 1 is equal to 2. Okay, so notice these two are the same. Okay, so I can combine it, log base 2. If it's minus, though, I'm not multiplying these two. I'm going to divide. So it's x minus 2 over x plus 1 equals 2. Okay, I need to convert it then. Convert this to an exponential. So 2 squared is equal to x minus 2 over x plus 1. Okay. At this point, I need to note that x cannot be negative 1. If I would work this out, okay, notice my restriction in domain. Okay, so I'm just going to keep this just in case that I get an answer of x cannot equal negative 1. So since x cannot equal negative 1, I can multiply this over. Okay, so it'd be 4 x plus 1 is equal to x minus 2. Distribute, so 4x plus 4 is equal to x minus 2. And then solve it out. I'm going to minus my x over, so that'd be 3x plus 4 is equal to negative 2. Minus my 4 over, so 3x is equal to negative 6. Divide by 3, x equals negative 2. Now I need to check that, okay, because I can't have negatives in here. So if I plug -2 in, -2 minus 2 is -4. Okay, so automatically I cannot, this is not a solution. Okay, so if that was the only solution I got and I plug it in and it's not one, okay, then it is, your answer is going to be no solution. Okay. All right. Now, the next one is a word problem. Okay, this is very common. How long for $1,800? So my principal value is $1,825. I want it to double. I get 9.5% interest. That's your R. And it's compounding continuously. That's keyword. Okay, so anytime you see this, you should know P is equal to E. No, I'm sorry. You should know that A, the amount that you want, is equal to PE to the RT. Okay, so I want it to double. Okay, so 1825 doubled. I want 3650. So that's my A. I got R, I got P, I need T. So want, so I'm looking for T. Okay, so plug everything in. So 3650 is equal to 1825. E to the rate, make sure your R is as a decimal, 0.095 T. Okay, so you set it up. Now you got to solve everything for T. So divide this off, and I get 2. 3650 divided by 1825 is equal to E to the 0.095 T. What gets rid of E? Well, that's natural log. So natural log of 2 is equal to the natural log of E to the 0.095 T. And those cross off. So I get, based on that, I get natural log of 2 is equal to 0.095 T. And if I want to solve it, I divide this off. Okay, so I divide by 0.095, both sides. And so I get ln of 2 divided by 0.095. And if you type that in your calculator, make sure the key is you close off the parenthesis there before you hit divided by. And you should get, when you type that in, you should get 7.2962. Now, in the instructions, it says round to the nearest 2 decimal places. Okay, so that's these two. Okay, so I look at this number. 6, we'll raise it up. I'll round up. So that would be, instead of 29, it'd be 30. So 7.30 years. Okay. All right, next one. Okay, so you're going to be given questions such as this. So 3 to the x minus 4 is equal to 734. Here you'll have to use logarithms. Anytime the exponential or the variables in the exponent, usually you have to use logarithms. Okay, so my base is 3, so it's log base 3, and then the answer, so 734 is equal to x minus 4. Remember, okay, so a to the b is equal to c, then log with your base of a of c is equal to b. Okay, this is the conversion. Okay, so, and I think that's on your formula sheet if you forget that. Okay, so to solve this, okay, I can solve this by using the change of base. So log of 734 divided by the log of the base, which is 3, is equal to x minus 4. Do the math on that. Make sure you close off your parenthesis there. And I get 6.006, so I'm going to go 6.0 x minus 4. And then I add 4, so x equals 10. Okay. All right, the next one. E to the negative 4x plus 11 is equal to 54. Again, what gets rid of E? Okay, and that's the natural log. So anytime E is your base, you have to use natural log. So natural log of e to the negative 4x plus 11 is equal to the natural log of 54. And notice those cross off. Okay, so I'm left with negative 4x plus 11 is equal to the natural log of 54. Okay. If they want an ever exact answer, you don't type this in. You just keep going. So you minus 11. So negative 4x is equal to the natural log of 54. And only that minus 11. And then you divide by negative 4. Okay. So it'd be the natural log of 54 minus 11 divided by negative 4. Okay. Which is, okay, and you should type this in your calculator. Make sure you are able to type it in your calculator correctly. 1.75. Okay. All right. Final one. Okay, we also have variables in the exponent. We have bases on both sides. 5, 3x plus 3. Notice that the base over here is 5. Can't really do anything with that. But 125, can I make it the same base and then I can cross the bases off? Well, 125 is the same thing as 5 cubed. Okay, and how I would think about that, 5 to the first, obviously 5. 5 squared is 25. 5 cubed is 125. And you can keep going. So if it had like 625, you could go 5 to the fourth, so on. Okay, so I'm going to replace 125 with 5 cubed. Okay, so 5 to the 8x plus 3 is equal to 5 cubed, which is 125, to the 3x plus 3. Okay, you'll distribute this, so 3 times those things. So it'd be 5 to the 8x plus 3 is equal to 5. And distribute the 3 to that and the 3 to that. So that would be 9x plus 9. And then my bases are the same. So I can just cross those off. And I get 8x plus 3 is equal to 9x plus 9. I can minus off 9x or 8x, and I get 3 is equal to x plus 9. To subtract off 9, I get x equals negative 6. And notice, the negative can go in the exponent. Anything has a negative exponent. But just make sure logarithms do not have negatives. You can't do negative logarithms. Okay, that's section 7.5. Let me know if you have any questions.